All right. So let me go in and get the example up for you of what we are going to be working on today. All right, now let me share my screen with you. There's like 700 steps on a Zoom meeting. Sweta, how are you?
Good to see
We
you.
did sing karaoke last night, so she can attest to exactly why my voice sounds like this.
Oh, I'm in a similar boat.
I
So.
got a little ambitious. It's fine. All right, so here we go. Can y'all see that?
Yes.
Yep.
Awesome. So here's what I'm going to do. Today we are talking about a system of analyzing risk in software systems. The hope is that this system will be accurate enough to be useful to you and also simple enough to be used so you can bring it back to your software teams. What we're going to do is we're going to break up into groups, and in those groups we're going to do a series of activities where we analyze risks in this application. So what you see here is a class model diagram of a system that is designed to help triage an emergency room for parrots. So you can think of this as like a specialized veterinary office. This is where parrots come when they have serious conditions, okay? And this system is designed to help make sure that those parrots are getting attention in the order that they need to get it. So there are a couple of different parts to this system, and I know that the text is kind of small right now. You'll be able to make this bigger on your end when you're looking at it yourselves in your groups. So there are a few different parts to this. I want to walk you through the application, the system rather, before we get started. So it gets information from 3 different sources, okay? 3 different sources to identify what order the parrots need to be seen in. First, it gets information from a breed information API. I'm going to move this red thing around so you can see where I am. A breed information API. So if the bird is of a particular breed, then you're going to get information about its vital signs, what you should expect to see from there. It also gets information from this iPad right here, where vets enter information about individual patients. So they might enter stuff about the patient history, for example, that you use to determine what severe looks like for these birds. So while the breed information is coming from a remote API, the patient information is coming from this iPad and it's stored on a shared database. And then finally, you're also getting information from a little Internet of Things device. It's a little harness that we have strapped onto each parrot that helps to get real-time information about their vital signs like their heart rate and their breathing rate and their temperature and how much they're moving around, those kinds of things. So those are your 3 sources of information where you get information about the birds. Then we collect all of that information and it goes to a condition risk evaluator. The condition risk evaluator determines what the risk is, what the risk level is for each bird. And then that goes to a prioritizer, and that prioritizer displays in order what order the birds need to be seen in. Now, if a bird has a risk that's above a certain threshold, it will also send a notification to the vet's phones to tell them to go take a look at that bird immediately. That's for emergency situations where the bird needs immediate attention. Does that make sense? Rock on. So what we're looking at here is a class model diagram where you'll be able to look at all of the classes in a rough kind of a sense that are involved in making this system happen. So here's what we're going to do is we're going to be doing 3 activities in groups of 4 where we annotate diagrams like this. In your group, you will have your own version of this diagram. But before we start doing those activities, we're going to talk a little bit about the different things that can go wrong in an app. Okay? Because typically, when we think about stuff that could go wrong, when we talk about the risks in an app, we tend to think about functionality risks, right? Stuff that might go wrong with a button or a lever or like a text entry or something like that. And those are important. But there are a number of different axes that we'd like you to be thinking about with regard to what can go wrong with an app. So, Lauren, would you like to go ahead and go through those?
Sounds good. I will share my screen.
Cool.
Okay. Let's make sure we got that going. All right. So now we're going to talk about what can actually go wrong in the application and how can we categorize these things. So the first thing that you think about probably when you're thinking about things to go wrong is a functionality risk. So that is something that just isn't working, or it's not working the way that you expect. That would be if you implemented something on your app and it's just broken. So that's when people think about bugs in an application, they typically will think about this. There's lots of other kinds, and we're going to go through those. And so the next one is scaling. This is something like if you have way too many people than you expect to be trying to get into your application at once, this could cause it to fail. Or if there's issues with the network that people are using, again, that's a similar problem. And so you want to consider how many people are going to be using the application or the database at once. Next, we have robustness. This is something that happens if someone gives an invalid input. For example, if you have a form for people to fill out that asks for their email and they put in some garbage data by accident, let's say they misformatted their email, then you try to send them an email and it fails, that would be an issue with robustness. And that's a little bit different from our next issue, which is security. And this is something where somebody will deliberately try to cause your application to fail by putting things into a form or, blasting your service, something like that. And that is different because people are doing this deliberately versus in this robustness one from before, that was by accident. Then we also have accessibility. This is for people who are relying on text enlargers, screen readers, captions, etc. But it's not just for the people that you might think of as like needing these things. It's also the people that just want them because they just like having larger text, or they like having a little bit more contrast because they're outside. So this would be all included in accessibility. And we want to consider that because if you have your text too small and it's not able to get enlarged, somebody might not be able to see it, and then they're doing things in the application that you didn't intend. And then finally, we have inclusion. This is also a little different from the last one for accessibility because this is about the people who need the application compared to probably the people who are building it and the decision makers of the application. So a really good example of this is for people who are building an app for children. The people who are building the app are not children themselves, probably, and they might not have kids. And so there could be some things that they might not have considered for how kids are using the app. Kids tend to just kind of click around at all different things, and you probably didn't intend for that. You expected them to click in a certain way. So this is something that we just want to consider, is including all of the people that might be using your application. So I think that with that, we're going to talk about what constitutes as a giant issue, right?
Yep.
Catastrophic.
Yeah. Yep. So first, here's what we're going to do. What we're going to do is we're going to divide into groups of 4. I have you in groups of 4, so hopefully you'll get to make some new friends and do a little bit of networking at RubyConf from your chair at home. And what we're going to do is you're going to get a version of this diagram, all your own for your group of 4. You can take pictures of yourselves with it. That's fine. But the first activity we're going to do is we're going to go in here, and I want you to identify what could go wrong in this system. Anything that could go wrong. It's I can be an anxious person, and this is like my dream activity. I'm so good at this. I can look at this diagram and identify things that can go wrong. So here's what you're going to do. This is a text box that you can copy and paste if you want to. Oop, that's the wrong thing. You can copy this text box and then paste it like that. And then you can bring it over to something just like this and say, for example, maybe the server goes down. That's something that can go wrong at that point in the app, right? Now, the way this is set up, all 4 of you should be able to simultaneously edit this diagram. What we'll do is we'll give you 10 minutes to do this. So I'm going to put you into your groups, and then we're going to take you out at 1:09 p.m. Central Time. Once again, I'm going to put you in your groups, and what you can do is copy and paste this text box and annotate all over the diagram all the things that you think could go wrong. And it's okay if several of you identify the same things. What you should end up with after these 10 minutes is this diagram with a bunch of red text all over it of all the things that you think could go wrong at each point. Now, we've provided for you a little comment over here to remind you about the types of different features that you could be looking for. So if you think you've identified all the different functionality that can go wrong, you can take a look at this note and go back through with an eye towards security or something, for example. Does that make sense? What questions do folks have about that activity? We're good?
Did you drop the link to the slides
It's
somewhere?
I will drop the link to the slides. That is a good point. Let me get it from right here for you. All right, I'm going to put it in the chat, and this is the way it's going to work. So let me stop sharing so that I can get access to my chat. The way this is going to work is you're going to get put in a breakout room, and your group number, you're going to see that that drive has group 1, group 2, group 3, etc. Your breakout room number is the same as your group number. So if you go into breakout room 1, then you're going to be on the slide for group 1. Does that make sense? Now, before I stick you in, I want to make one last recommendation, which is to please, if you can, I understand not everybody can, but if you can, please go ahead and turn on your video and audio for this, because that's really the closest that we can assimilate having like a real face-to-face experience at RubyConf right now. And I know you might not necessarily be able to, but it really does help with the collaborative aspect of this, okay? Rock on. Okie dokie. So what I'm going to do is I'm going to open the rooms, give you 10 minutes. We're going to come back at 10 minutes past the hour, okay? All right, off you go. Welcome back, welcome back. We'll give people their full 41 seconds. This activity, sometimes folks come back early from. Other activities, sometimes people wait out the whole thing. What I'm going to go ahead and do is open up everybody's diagrams so we could look at all this work everybody's done on my screen. Should be really exciting. I really hope Chrome doesn't freeze on me. Nobody say anything and maybe it won't notice I'm opening tabs. It's like bird watching. You have to be very quiet.
So jarring.
Welcome back.
Just got yanked.
I'm sorry.
No.
We missed you guys. We needed you back with us.
Trying so hard to. Oh, man. What'd y'all think of that activity? Did you find a lot of stuff?
Yes.
A lot of stuff that could go wrong. Do we want to go through and take a look at what we thought?
Yeah, let's do it.
Yeah.
Let's do it. Let me
Okay.
share my screen with you. You can see this?
Yeah, we
Yeah.
can see
Yes.
it.
It's big enough. So this is group 1. All right. So this is what group 1 thought could go wrong in the app. So we got bad data from the breed information API, definitely. No validation on the iPad. That's a huge one, right? Human entered data is a massive risk, especially when you've got, 5 highly qualified, stressed out human beings running around with birds. That's probably not a recipe for high quality data entry. For those of you, I don't keep a bird, but for those of you who do, you will know that it's very similar to having a 5-year-old in your house for 75 years. So if you're running a facility with 3 dozen sick ones, can't imagine it's very easy to pay attention. We could have a faulty connection On the bird harness, that's definitely true. The service could go down always. Everything could always go down, right? That's always a concern, especially if it's, an exotic bird hospital facility. There's a non-negligible chance that this software is going to be deployed, I don't know, at a building next to the Amazon basin or something. Probably not the best connectivity. And then we've got the vet's phone is off or is in
Do not disturb.
disturb. Yeah, you know exactly what I thought that was.
Yeah.
Do not disturb mode. That's definitely an issue that we could potentially have to deal with. Or the architects don't have enough time to identify. How did you get me 70% of the way through reading that before I saw what it was?
We were just
Trolls.
starting to get our groove on and figure out how to actually do what we were trying to do and think about this when we got yanked back into the main room. So,
Nice. Well,
so
You're gonna have
we felt
plenty of
that
time to
very
go
real
back.
Problem of like we just don't have enough time to figure this out, which is an
Oh,
actual
man,
problem.
yeah.
So
it's an actual problem. That's why we need to have a simple enough to be used kind of system because it really does happen.
mhm.
All right, let's take a look at group 2. Oh, wow, there's a lot of things. All right, group 2, what we got in here? May not account for all payloads from the API. Definitely really sucks when your API changes format and you don't know about that on the client. That's the worst. Vet enters information for the wrong parrot. iPad battery dies. Someone changes the password. The iPad is locked. These are all definitely real things. The Internet of Things is highly exploitable, so it's not secure. That's definitely true. Parrot flies out of range. Ooh, we've got an escapee parrot. I haven't heard of that one before, but definitely something they would do. Might be removed by other parrots. That's also true. The parrots get in a fight, or they get in. They decide that they're gonna form a union and take the harnesses off of each other. That could absolutely happen. A database failure doesn't account for ambient weather. Crashes due to too many calls. We've got a DDoS error there. Algorithm doesn't surface conditions that require a quick response. Yeah, maybe it doesn't know about an acute condition. False positives for some of the values could trigger an unwanted notification. Definitely. If there's too many false positives, we see this all the time with integration tests. If they start failing for reasons that don't have to do with the software being broken, devs stop paying attention.
Yeah.
Ends up being a huge problem. Love it. All right. Let's take a look at group 3.
Can you
Group-
make it a little bigger?
Can I make it bigger?
You
Did
can
that make
collapse
it
the
bigger?
pane on the left. That might help. I think
How
you
do I
can,
do
like,
that?
Or click present.
Yeah, that.
Present. Can y'all see that? Oh, this is where
Yeah.
the-
Much better.
Yeah.
Yes. Okay. All right. Okay. So group 3, server crashes, can't get data from the server. Harness doesn't fit totally, doesn't gather the data that you need. Stop talking to all the devices on the network, on the database. That could absolutely happen. Happens all the time. Data gets saved incorrectly. I want to stop at this one because that's a really important one. We're going to be talking a lot more about that in the next section. So group 3, good catch. This is one we're going to identify a couple more things about. Patient history gets hacked. Absolutely. We got a security vulnerability there. Who knows? Somebody might get in there and start trying to, I don't know, blackmail parrots for their health history. Or there could be personal health information leaked. It's illegal to do that for humans. I don't know about for parrots, but it's something for us to be aware of. Information gets transcribed incorrectly. It could totally happen. Prioritizer makes the wrong call. Does not alert the doctor of an urgent issue. Totally. There are a lot of concerns around the condition risk evaluator and the prioritizer. Last time we gave this workshop, somebody correctly identified that those two classes are essentially performing the role of a triage nurse, which is, of course, a highly trained person. And so there are really important considerations around this with regard to, like, what can we safely automate and at what point does a human with training need to come in?
Hi.
Oh, hello. We got our newest conscript. I don't know how to stop. Okay, here we go. Now, okay, let's look at group 4. Group 4. Application and iPad incompatibility. Yes, compatibility issues could totally be a problem. Harness falls off, definitely. There's one here that I haven't seen yet. I've seen something close. We'll identify it at the end. Robustness, parsing unexpected input into XML, totally a problem. Data scalability, for sure. How many parrots are we talking about? Can we move fast enough? Can we identify? Can we crunch enough data? Scaling, once again, too many calls at the same time. Scaling is a big one anytime you're trying to like aggregate a ton of information. I see really slow page loads on pages where they're trying to crunch data live and provide a nice visualization. It just ends up being so much data, right? And then notifications failing to deliver. This is a big one. This is something to think about. I might be wrong. I don't think any group mentioned, one group mentioned parrots ripping off each other's harnesses. I didn't see anybody mention parrots ripping off their own harnesses, which is something they absolutely do all the time, and it's really annoying. But that would be another potential issue here. Although I don't know whether you would file that under robustness or security, because technically that is a deliberate exploit, but I don't know if we're going to say the parrots exactly have free will on that. Are parrots
Yes.
hackers?
That it's definitely an exploit. Absolutely. Yes. I would categorize that.
Security risk from black hat kaiques or something like that. You don't know how long I've been waiting to make that pun. All right. So y'all did a great job identifying a whole bunch of stuff that could go wrong. I'm going to say off the bat, I think group 2 has the highest anxiety. That's my guess based on what I've seen. I could be wrong. So that's great. We have a whole bunch of different risks. There's a lot of them, right? Every single group identified more risks than we would be able to ameliorate at one time, right? So we have to figure out a way to prioritize these risks. And that's tough, right? How are we going to go about doing that? So the next thing we're going to do is talk about a system you can use for prioritizing those risks. And then we're going to go back and try it. How does that sound? Sound like a plan? All right, Lauren, I'm going to let you take it away.
Okay, so I will share my screen a little bit. Let's get that going. Okay, cool. Can you all see it?
Yes.
Okay, I'm just going to share one of the teams. So you can see these circles here. We've got catastrophic, likely to happen, and likely to go uncaught. So number 1, you're going to put that next to all of the issues that or the risks that you discovered that you think are catastrophic. Then 2, obviously you're going to do the same thing, likely to happen and likely to go uncaught. So I think what I also want to do before we start that is to talk about or to discuss, like, what do we think catastrophic actually means? And like, what would be considered catastrophic for this specific application? Does anyone have any comments they think, like, what would make, what's the level we should go at for catastrophic?
Dead parrot.
A dead parrot.
Yeah.
All right.
Do we think
I
that?
feel like
Oh, yeah.
catastrophic could be anything that to the level where the system is completely unusable. So like if I am unable to solve the problem that I'm trying to solve with this solution, then that's catastrophic.
Okay. So we want to keep parrots alive and we want to keep the application usable. And so what do we think are the main things that need to be able to get used? It needs to, I guess, send the proper information to where it needs to go and be able to enter the information correctly, right?
Yeah.
Okay.
In talking about dead parrots, like specifically parrots that like could have been saved if it happened faster, right?
Yeah.
Like the time. I think of like things later in the chain is really important because those feel like those critical steps.
For sure.
Yeah, that's a good point. With like a code blue parrot, it's really important to identify those.
Right. Yeah. Okay. Cool. So what you're going to do is in your chart, we have these letter numbers. These are movable. So you should be able to copy this and put it wherever you want next to your risks. And then we'll come back, we'll regroup and talk about how we've scored all of these. Sound good? Anything to add, Chelsea?
Yeah, one quick ad. And now I forget what it was. So we talked about catastrophic a little bit. Likely to go wrong. These are things that, that where the software, you've seen situations like this break before. This is a fragile thing where you already know that there is risk versus like, I don't know, the programming language becoming completely out of date. Just like things that are less likely, you maybe wouldn't put this next to. 3, likely to go uncaught. I wanted to just touch on specifically because I think it was group 3 that identified issues in the data right there in the center with the condition risk evaluator. So likely to go uncaught, these are the kinds of things where, and I see these most often in stuff that has to do with databases. And so there are two reasons for that. The first reason is that it might be possible to put in information that is valid according to the validations on the format in the database, but is just incorrect. So examples of this might be situations where the database requires a text string, and what you put in was a text string, and so it passes the validations, but it's in the wrong encoding, and so when you get it back out, it's garbage. So that's the first way that this can happen. And the second way that this can happen is because databases are a particular vulnerability that attackers are going for. And the thing about a successful hack where the goal is for them to get data is that if they've done it right, you don't notice. And the reason for that is that then they get to keep access to your data for an extended period of time. So the database is a risky spot around this. The other big thing about this is that if you're losing data, like if an app breaks, you can fix an app. If you lost data, there's like not a way to undo that. You can't get that back. And so with the database in particular, that likely to go uncaught modifier is when you're going to see a lot around stuff that can go wrong in there. Does that all make sense? What questions do folks have?
Are we?
So it's like, so even if an issue is likely to go uncaught, it doesn't necessarily mean that that's like, oh, cool, we don't have to worry about that, right? Because, you know, if my database gets hacked and, you know, bad actors can just like constantly check, you know, who signed up for my app, like that's catastrophic, right? But maybe take a while for me to notice, you know, my users will suddenly be all the victims of credit card scams, and then that's how I find out, right? So, so I think am I right in making that like kind of like distinction that like, you know, even if it's unlikely, even if it's likely to go uncaught, that doesn't necessarily mean that it's not catastrophic.
Right. Yeah, that's absolutely true. There's all kinds of interesting, and I'm glad you brought that up, because there are a lot of interactions between these three risk amplifiers, right? If like you mentioned, if it's likely to go uncaught, then it can end up being catastrophic. If it's likely to go wrong, then it can end up happening enough that it ends up being catastrophic. So those types of things, they complicate things a little bit for sure. And so here's the way that we're going to address this for now. Once again, we're trying to put an imperfect model on top of a pretty complicated system. So here's what we'll do is, the first thing is that you can put any number of labels on a risk. So you don't have to choose between whether it's a 1 or a 3. You can put a 1 and a 3 on the same risk. And in fact, you should for this activity if you think that that's the case. And if you're thinking about one risk potentially leading to another, one risk amplifier leading to another, you can go ahead and put both of those onto the risk as well. For example, if you think the fact that it's likely to go uncaught is going to lead to a catastrophe, you could put a 1 and 3 both on that risk. Does that make sense to folks?
Mm-hmm.
Are we? Right. I just have a. Are we listing things on like? Are we like putting? Or are we just saying this system is at risk of 1 and 3?
You can just put the 1 and 3. You don't have to elaborate.
Like itemize it or anything. All right, thank you.
No, yeah, that saves time.
You put the numbers next to each risk, not like the whole system as a whole.
Okay. All right.
Yeah.
So the final thing before I break you out is that for this activity, we highly recommend identifying a proctor in your group to say, okay, we're talking about this risk. What do you think the labels should be? Okay, we're going to move on and talk about this risk. What do you think the labels should be? Tends to make it go a little bit smoother. And we're going to give you about 11 minutes for this one, okay? Y'all ready? Excited to prioritize some risks? All right, here we go. I'm going to put you in your groups. Get excited. Welcome back. Welcome back. We'll give folks their full 40 seconds to finish up adding their risk amplifiers, prioritizing their risks. Did y'all find that you were adding risk amplifiers to most of your risks or just a few of them? How'd it go?
All of them had risk amplifiers.
Did some have more than others?
definitely.
Or was all just everything's going to break down all the time, everywhere?
No.
Everything's catastrophic.
I mean, some were. I feel like we were like thinking long term, like, okay, yes, this could become catastrophic if we don't do anything about it. But there are simple steps that we could take, like right now, to avoid a catastrophic failure from like even happening.
Yeah, it's true. Did you also talk about like what it means to be likely to happen? Like how, you know, what constitutes as likely, or like likely to go on call? Like how likely does it have to be considered likely?
Right.
Too much thinking into each of these, you know?
Yeah, I think we had some situations where different lived experiences led to different decisions of like around scaling. Like for example, I've been mostly in B2B environments where it's pretty obvious when things need to scale versus like if something like if I guess this is like this goes viral because like the parrots are everywhere, but I kind of thought of it more of like a B2B. Like you have to the harnesses are the limiting factor in scale, but
yeah, that's a good point. I guess unless like a lot of bird hospitals end up taking up our application, right? We get a lot of new bird subscriptions.
How many bird hospitals do we think there are? Just period.
That's a good question.
I mean, I feel like most major cities have like veterinary specialists. So if nothing else, like I feel like there would be a market for this in like major metros.
Makes sense.
Lots of sick birds, and we're gonna save them.
We are.
Lauren, would you like me to share my screen for you to regroup, or would you like to share your screen?
I can share mine. It's
okay.
Totally fine. Okay, let's get to the regroup. Let me share my screen. Okay, I'm going to start with group 4 because, you know, we usually start with group 1, so why not? Okay, so let's talk about like what you guys chose for your 1, 2s, and 3s. Looks like we've got mostly like double sets. I don't think, let's see. It looks like this one has all 3 of them. Prioritizer fails to compare value against threshold. Okay, that's a good one for sure. Which ones of these do you guys think would be like the worst one? Would it be this one from group 4?
Yeah, I think so. The the prioritizer one.
Yeah.
I think.
So what was your justification for choosing some of these numbers?
I mean, Colin came up with that one, so he can probably speak to it better than I can. But I know that it was like that comes from like lived experience on our team, so I found that was pretty key.
Okay.
Biggest
Colin,
one.
Do you have any insights?
Yeah, where it sits on the tree. If the prioritizer fails, the vet never gets the notification. And what we talked about right before we broke into groups is that that's the intervention that the app is designed to provide. So like all of these different services
for sure.
provide intervention. So
yeah, I mean, if this is at the end and one of these upstream or downstream, I guess, however you want to say it, fails, I guess it's going to fail possibly on the prioritizer. And that seems pretty catastrophic if the app doesn't work. What about some of these other ones? Let's see, like harness falls off. That definitely seems pretty likely to happen if, or if the bird, you know, birds could be different sizes, right? Cool. Anything else that group 4 wants to add? Nope. Okay. So let's move on. Let's check out group 3 and see how group 3 did, what they came up with. I was telling group 3, I really like the set of numbers they had to easily move them around. Good thinking. So let's see what you got. So this one looks like it's got a lot. Screen reader incompatible with how content is written. Definitely. That seems like it could be pretty bad. So do you guys think this one's the worst one, or do you have another one that you think would be possibly the worst?
My thought would be actually the notification not being delivered would be the most catastrophic.
This one.
Just because everything else could be working and then that falls down at the last hurdle. I mean, if the prioritizer got it wrong and it was a code 3 rather than a code 4, the vet still may attend. But if it doesn't get notification, then not going to.
Yeah, that's true. Yeah, if there's a sick bird and they have no idea, then the sick bird might die.
I think quantifying which of these failures is the worst or like the most catastrophic is kind of like I mean, if a person can't access the content to submit the information to the app, then none of this is going to work, right? Because it's not even, you're not going to have the data to begin with to even have the prioritizer do the thing that it needs to do to determine if immediate intervention is necessary. So like going back to like screen reader incompatible with how content is written being the most catastrophic. I mean, what's the most catastrophic is going to depend on the user. It's also going to depend on like a variety of different factors. And so I think it's important for us as developers to understand that catastrophe is going to look really different and to remember that, if a person can't, especially with accessibility and with inclusion, if a person can't access the service, then it doesn't matter if the service is working perfectly all the way at the prioritizer end. If I can't even get to, put in the data that it needs to run, then that is a catastrophic failure. I don't know. Does that make sense?
Yeah, that makes sense. Like that, if you have a screen reader, that this would be catastrophic and this would be likely and uncaught. But if you don't, then maybe one of these other ones would be the worst.
Right. So depending on like who you are, like what you're bringing to the table can influence what would be the most catastrophic failure here.
Yeah. And like if that person is a sole user, if they're, if they need this screen reader, then that seems pretty bad.
Right.
For sure. Cool. Anything else group 3 wants to add? No. Okay. It looks pretty good. Let's see how what group 2 came up with. Okay. So we've got lots of singletons here, and then we've got a few. So performance issues that are likely and pretty likely to go uncaught. Doesn't account for ambient weather. That's true. That seems pretty likely. So let's see about this one. Vet enters information for the wrong parrot is catastrophic. Okay. Yeah, that doesn't seem too good. If they're getting wrong information, it seems pretty likely if all the parrots look the same. Cool. So group 2, what do you guys think would be the worst one on here that you have?
I think it was kind of interesting, like that from like the exercise, it kind of feels like human error is actually the biggest issue here, because it could like the data entry, if that's like easy to not be caught, not that hard to happen, and like can end up with dead parrots. So it was just interesting to kind of I think the thing that kind of came up for us was like the database area and things that go into it stood out to at least me. Curious what other people think.
Yeah, I think that makes total sense. And also like, I find that whatever I'm working on at the time, I like think so much about that. So when I was a product manager, I was like thinking about, the product as a whole. And now I'm a software engineer and I'm like, but the back end, the back end is so important. And so like, but then, I feel like I've just learned that every part has like these huge issues that could happen, and you got to think about all of them. Cool. Anything else to add from group 2? All right, let's check out group 1, see what they came up with. Group 1. All right. So we've got a few that have 3 on them. So, or actually, yeah, this is 1, right? Concurrent modification system issues. Is that 1 or is that 2?
Those are two separate.
That's 2. Okay.
Yeah, those are 2 separate issues.
Are these 2 separate ones?
That's the same. Those are the same.
It's kind of the same
one. Okay. So, but it seems like a lot of people have the similar type stuff, like this human validation or like human error, typos, no validation in the app.
They're the worst part.
Yeah. Humans are the worst. We just need birds.
It's always the human element is always the one that goes wrong. Like they could be trained improperly. They could, maybe it's like secondhand training, right? Where it's like they're not getting the information isn't getting passed down the line properly. So maybe one nurse teaches they're like, oh, don't do it that way. It's like, it's slow and whatever. And they teach them another way, but it's off of like the SOP. So they're doing it wrong and then data is getting put in incorrectly or something along those lines, right? So usually anytime where there's user input is where a big one happens.
Yeah.
One of the things too that I see a lot of is like if the user interface is designed by someone who doesn't actually do that job or like isn't on the other side of it. A lot of times the UI is like not necessarily conducive towards entering the information correctly or efficiently.
Yeah, like what if they're monitoring the temperature of the parrot and the developer uses Celsius and the person using it uses Fahrenheit? Like that seems like it would be.
Or like a text box instead of like a number selector kind of thing, or like those types of UI kind of elements. I see a lot.
Yeah.
Yeah.
Yeah, that's why it's so important to do like to just know who your user is and also like do user interviews and that kind of thing. Cool. Anything else to add for group 1?
I think I saw a lot of people were talking about too much data going into the condition risk evaluator, but something that we had identified was it's not necessarily too much data, but if one of the other services go down, there could be deadlocking because they're not getting all the data they need to resolve. And if there's no basically like timeout conditioning or anything like that, you could just end up with all your workers like idling, waiting for the final bit of data to come in. And it's not necessarily that you are getting too many requests. It's that you're not getting all the data to resolve it, right?
Yeah. Yeah, that makes sense. Cool. All right, Chelsea, anything to add or I'll pass it back to you. You there, Chelsea?
I'm here. Can you hear me?
Yeah.
Okay. I feel like that's an obligatory part of every single Zoom call. Am I muted? Can you hear me? What's going on? Can you see me?
Yep.
That's the baby I have to mute. Wait. Cool. So we have identified risks. That's the first part. Identified all these different things that can go wrong in our app, right? And we looked at a whole bunch of different categories. We looked at functionality. We looked at security. We looked at robustness. We looked at inclusion. We looked at accessibility. So we got all our risks. We identified we can't address all of these at once. So then we labeled them with some risk amplifiers. 3 risk amplifiers, right? How catastrophic is it? How likely is it to go wrong? And how likely is it to go uncaught? Those are our 3 risk amplifiers. So now that we've addressed all of our risks with these amplifiers, we can start to consider how we would go about prioritizing these risks. Now, eventually we may have to come up with some kind of list, right? We're going to address this first, this second, and so on and so forth. And maybe they don't have to go one by one. Maybe we have multiple different tracks of engineers who can address them simultaneously. But there are things that do have to happen first and things that can wait until maybe a little later. And then the question is like how we address them. So those are the 2 things that we're going to talk about next. First one, what order, and then how we're going to address them. So in terms of order, what I like to do is look at my diagram. And once I have those risk amplifiers on there, what really sticks out, as you may have seen in our regroup, is the ones that have all 3 of them or 2 of them. Those are the ones that tend to be the places where I need to start in terms of priority, the ones that have the most of them on there. Now, that simplifies things a little bit, right? Because sometimes maybe some of the risk amplifiers are more important than others in certain circumstances. Sometimes there's one, maybe catastrophicness feels like it should override all the others or something like that. Those are the kinds of judgments that are valuable for you as a software team and for you as a human being to be able to make about the priority of the different risks in your app. This system isn't designed to provide you with complete and correct answers with regard to what needs to be addressed first. What it is it's a tool, it's a framework to help you visualize. These are all the things that could go wrong. This is a rough estimate of what could potentially be the most bad. And then you can go in and override that. You can go in and determine your priority list with the help of those risk amplifiers. But what they do is they get your team talking about much more specific questions. And most importantly, they get your team talking about the same 3 questions for all the different risks. And the reason that that's valuable is that sometimes it can be really easy in engineering meetings to talk past each other, right? About, well, I think this is important because it's catastrophic. Well, I think this is important because it's really likely. And that type of thing, it's helpful for us to gain a common understanding of what we're talking about and how we're evaluating it. That ends up giving us an easier footing for for making meaningful decisions in less time. And it also cuts down on a lot of disagreement in the group because it cuts down on a lot of the miscommunication that causes disagreement that isn't actually disagreement. It's just miscommunication. Does that make sense?
Yep.
Rock on. So that's what we got. Next, we're going to talk a little bit about like what we do about all this stuff, right? So I went into a couple of these groups kind of towards the end there, and they had all their risks labeled, all their amplifiers on there, and they were talking about, all right, one group in particular was saying, so we have this risk that the vets aren't going to receive the notifications. What we're doing is we're trying to figure out what we would do about that. How do we address that? And so that's what we're going to talk about now, is a couple different ways that you can address these risks. Now, I should mention that what we're going to talk about is not necessarily a complete list. It's a couple of things to get you started. We left a few things off of this list, but these will be things that will be helpful to you in making this judgment about what might be most useful for us to take a look at. So let me go ahead and open this. Let me see if I can share my screen. I really love some of the functionality that I get from Google Docs, but I cannot call it the fastest tool.
Nope.
Which is okay, maybe. All right, so what I'm going to do here is I'm going to open up the notes for you. We're going to talk about 3 different categories, which you will probably recognize from our previous conversation about 3 categories. So we talked about catastrophes, we talked about likelihood, we talked about things going uncaught. So this is also how we're going to talk about our different mitigation strategies. Because how do we deal with these risks that are catastrophic or likely or might go uncaught? Well, we want to reduce the consequences, right? Hopefully make them not catastrophic. We want to reduce the likelihood that something's going to go wrong. And we want to make it easier to catch things when they do go wrong, so that hopefully we can lower the overall risk profile of our application. Now, in a working production application, there will always be a risk profile. It's that I have seen it is not possible to eliminate a risk profile. At the very least, because as any good InfoSec person will tell you, there is no way to make an app unhackable. There is only making the app extremely annoying to hack, to the point that people will not put in the time and effort to do it.
Yep.
So, and that happens to be the case as well with a lot of our different things that could go wrong. Security being one, accessibility being one, functionality being one. There's always something, right? But what can we do? So let's talk about these 3 things. Maybe if we want to reduce consequences, say we want to address our catastrophic risks, right? How do we make them less catastrophic? Well, there are a few different things we can do. I wanted to provide some examples. One example would be increasing improving our fallbacks. So this is, say you don't get some data from a certain service, say it's from the Bird API, that API is down, and your risk prioritizer will not prioritize without that data. What are we going to do about that? That is a single point of failure that we really need to deal with. One of the things that we could do there is we could say, all right, are there sensible defaults here? Is there like a base range heart rate that most parrots are going to live if they're in, or something like that? And we can be more specific with our breed API, but we've got some fallbacks that make some kind of sense. They provide some kind of information that's useful. You'll see this, maybe this wouldn't be considered a catastrophic situation, but you'll see fallbacks like this in email lists if they address you hello friend or hello colleague or something like that, because you didn't put your name in somewhere, but it tries to come up with a default that doesn't sound that impersonal. And it ends up being better than like curly brace name in the middle. So that'd be an example of that. So that's one thing we can do to reduce our consequences. Another thing we can do is increase tolerances. So if somebody's phone goes all the way down on its battery, then you're not going to be able to get notifications. They won't be able to get notifications about the birds. So what can we do about that? Well, an example might be, suppose this app had a feature to keep track of where all the vets were at a given time. What that's doing is it's tracking location constantly, and tracking location constantly is an excellent way to absolutely destroy your battery. It is a great way to go from 100% to 20% in like an hour. So maybe what we do is we introduce a low power mode, and when the battery gets below a certain amount, we stop tracking location. Because the critical feature of this application is that if a bird is really the worse for wear, if we have a code blue bird, for example, and it's gonna die without attention, some vet finds out. And in order to protect that core functionality, we're prepared to turn off other functionality to increase the time span for which the core functionality works. That's one way we could reduce catastrophic consequences. Another one is redundancy. So this one I want to talk about specifically because it's really valuable for hardware and it can be super annoying in software. So we want to have a good idea of where to use this. It's really useful for example, a backup server or a backup cell network. Say that this is deployed somewhere near the Amazon rainforest and there's not particularly good cell service or something. We might want to have a backup there. The place not to use redundancy usually is with like multiple property checks in the software or something like that. Because then what happens is, suppose that we really need to make sure that something always gets printed out in uppercase. And so we turn it into uppercase like 3 separate places in the app just to triple check. And then the product manager comes to us and says, actually, no, this is going to be lowercase now. So somebody goes and they find it in the code and they remove one of the 2 uppercases and they figure we're done. But then the problem isn't fixed because what we have is redundancy on the software. That's a really good example of where this can get super annoying. Somewhat similar issue is in CSS when you mark things as important and stuff like down the line isn't changing and people don't know why the CSS is broken until they find your important class. These are examples of situations where using this technique on software is not advisable the way using it on hardware might be. Does that make sense? Rock on. So maybe we can reduce the consequences, make things not so catastrophic. How about the likelihood? How do we reduce the likelihood that stuff is going to go wrong? Now, this is the area where I see teams generally are the most advanced. This is where I see the most going on teams. First one's with automated testing, unit tests, integration tests, regression tests, just ways to make sure that like, hey, if something's broken that we know might break, a test is going to fail. So we're not going to be able to push without knowing that that's going to happen. We talk a fair amount about automated testing in the Ruby community, so it's one that I'm pretty confident folks like have a little bit of grounding in. But there are a couple other things that we can do too, because sometimes automated testing, we've all seen an app that isn't 100% tested. I have seen very few apps that were 100% tested, as a matter of fact. And so clearly there are situations where it's either too costly or maybe not even that useful in certain cases. There are situations where an automated test isn't going to catch us. It's not going to catch us on something that's wrong that it never occurred to a developer could go wrong, because a developer has to anticipate it for there to be an automated test about it. And as much as we would like to believe we know everything, there are chance miraculous occasions where that turns out not to be so true. So here are some other things I've seen really work for teams. The first one is quality assurance. It's having a QA team that is specifically trained and experienced in figuring out how your app's going to break and empowering them to say, we say the app shouldn't go. So if your head QA person says, this does not go to prod today, it does not go to prod that day. It does not matter what the developers say. It does not matter what the product manager says. Because if something that's going to break everything is about to go to prod and QA knows it, we have to respect that. So that's quality assurance, especially valuable on mobile apps where a lot of like UI stuff can go wrong really easily. And then, now this is the one that I've seen be the most useful in terms of like an 80-20 solution for teams where they have a completely untested app and they don't have a QA team, but they got to do something. A regression checklist is a great way to get started. This is literally a list of functions that need to work in the app, and the CTO or a product manager or somebody goes through this entire list every single time we go to production. It's probably not going to include a ton of edge cases. It's probably going to be mostly your main use case, and it's absolutely going to miss things. But in terms of minimum time to get from nothing to something, a regression checklist is really valuable. So that's reducing the likelihood of things going wrong in our app. How about things going uncaught? What can we do there? So this one's insidious and complex, and a lot of the mitigation strategies are also kind of complex. But one thing we can do there is to use frequent and descriptive logging. There's a really excellent book. It's called Release It, which I highly recommend taking a look at. And it talks a lot about means that you might use to log. Because ultimately, when something is in prod, if something's happening that we don't think should be happening, us saying it shouldn't do that doesn't change the reality that something's going on. And so we've got to be able to go in and identify what is happening, despite the fact that we've already released it. And the only information we're going to get is information we already decided to log. So having frequent and descriptive logging can be really helpful. And formatting our logs to make them as helpful in finding the problem as possible can be really, really useful there. We've all seen an error message that it turns out we ended up fixing it and the error message was 0% helpful. Totally orthogonal, maybe even a red herring that distracted us from the real problem. We want to do as much as we can to make sure that our logs point us in the right direction, not the wrong direction. So that's one thing we can do to increase catchability. I'm also a big fan of penetration testing for this. This is where you get, similar to a QA team, this is where you get somebody who is specifically trained to find exploits in your application, and you give them access to the application, and you ask them to try to hack it. And they try to hack it, and then they bring you a report of what could be hacked. So that can help you catch some of that stuff before it ends up really causing a problem. Super useful because it's especially directed towards security concerns, which are a big area where stuff doesn't get caught because it is by design hard to catch. And then a somewhat similar one is auditing. So this is going through and ensuring that various security protocols are met. If you work in an enterprise, your app may already be automatically subjected to auditing for legal reasons. But even if you're not, it's a good thing to do to go through and identify like where could something be going wrong in the app that I might not catch. In particular, database auditing is useful. I'm going to spot check some of the data in my database, and I'm going to make sure that even if things are passing all of my format validations, it's like actually also correct data. What questions do y'all have about those mitigation strategies?
I think there's like a really interesting tension between reduce consequences and increase catchability, where like if you reduce the consequence of an issue happening, it might also, you might not realize that like you're using that fallback default or something like that.
Mm-hmm. Yeah, that's a good point. This is another area where the different strategies can like impact each other. We're definitely simplifying a much more complex problem space with these. All right, are we ready to try to apply some of these to our highest risks? So here's what we're going to do. We're going to put you back in your groups for one last activity. One last one. I would recommend using your proctor again. Go through these and mitigate one by one. What you're going to do is you're going to start with your riskiest risks. However you decide to inform that. I would recommend using the risk amplifiers to inform that decision, but I'm going to leave it up to you. You're professional software engineers. You know how to do this. What you're going to do is you're going to go in, you're going to add text boxes for the mitigations you would like to use for the highest priority risks. And let's get as far down our mitigation plan as we can before I pull you back, okay? I'm going to give you about 9 minutes. I would like you to put the text in blue if you can, so we can identify them separately from the risks, but I don't want it to be in green because you can tell red and blue apart more easily if you're red-green colorblind than if it's red and green. Does that make sense? All right, I'm about to put you in your groups. On your mark, get set. Go. Alex, Travis, did y'all get invites or should I resend? What's done is done. All right, here we go. Welcome back. Welcome back.
Hello.
How'd that activity go?
That was a really fast 9 minutes.
We were just
Was.
we were just getting into the flow, you know.
Oh man. It's fast. It's a fast one. It does give you a chance to do your priorities though. Figure out how you're going to prioritize things. Shall we take a look? Let me share my screen with you. Start with group 4, as we have been doing. I see some, something's going on here. Sentry alerting. All right. All right. Let's see. I see monitoring for lack of data from a harness as a mitigation strategy for the harness falling off. I see some Sentry alerting ones. Tell us a little bit about alerting.
Like, I think we're just thinking of like because if we're assuming we have some kind of error logging service to make sure that we can flag particular particular errors as like, if I see this class of error like around XML parsing, I should get notified about it.
Mm-hmm.
If that's like an important error.
Yeah, I like that. I love the idea of including explicit testing against the prioritizer in particular. In areas like that, where it's going to be logic that might fail, automated tests are particularly useful because you can tend to anticipate what might happen there. And that's also a really good place to identify where a sensible default might be necessary. There's this excellent book. It's called Confident Ruby. It's by Avdi Grimm. And it talks about the 4 parts of a method. And I find that it's also useful for thinking about like system level applications, how the first thing you do is collect input and validate the input. And then you might like do your work and then you're doing the outputs. And it's a really useful description of this concept. Also, I noticed for the databases, we got backups once a week, a follower database, low power mode. This all makes total sense. Stacking up those mitigation strategies against that database, the part where you might end up with the longest running issues if you're not careful. Let's take a look at group 3. All right, we got starting in the top center, complete the API data, work with other Parrot hospitals and academic institutions to compile a complete list. Definitely. If our concern is that we might have incomplete data, that's something that we can mitigate on the front end, right? By making sure that the data is there. And this one's not necessarily even a technical mitigation. It might be an information mitigation, which is also useful. And then at the very end, we're talking about sending a read receipt. So if the message doesn't go through, then we default to email. If the client doesn't, then default to another backup. I like this. I've seen this. We start with an iMessage, then maybe we go to email, then maybe we go to text message. And if none of that works, maybe it can be like a sound alert or something like that. Having this sort of escalation strategy can be really, really useful. And I noticed the concern about catchability there, making sure you get a read receipt. On the database, I see health checks, totally. On the API, I see alerts for breed queries that we don't have. So maybe we'll be able to go back and ameliorate that by adding the information later. I like that, improving catchability. I see a lot of good mitigation strategies in here for improving catchability. Nice work. All right, let's look at group 2. All right, so on group 2, we got increasing catchability with validation checks on the picture ID. I like that. So this one, it looks like it's dealing with robustness as well as security. Robustness meaning that if you are entering data into the system, we want to make sure that that data is entered correctly. We also want to make sure that the right people are entering data into the system. And so doing some kind of a security measure involving the ID, the person's badge, might be a good idea. We have badge in at most hospitals. It makes sense for them to be on data entry too, right? And then all the way on the other end, we have reducing the consequences by sending to multiple people using redundancy. Yeah, we could send any given notification to the vet who's supposed to be on the ward and maybe another vet just to make sure. And then maybe we can have a policy in place or something that the vet who's not on the ward also needs to text and potentially even call the vet who is on the ward, so that maybe when they get a notification, they just see the bird and they let the other one know, you know, I'm seeing to this. And if not, then they call each other. That's a great strategy. I really like that. Finally, let's look at group 1. All right, what we got? On the iPad, input testing. Yeah, really useful to have automated testing here. User guidance through tooltips. QA empowerment, definitely. We're looking at a mobile app here where there's going to be a lot of user input. Really valuable to have QA on task here. And then on the breed info API, caching of responses. Sorry, what were you going to say?
Caching, yeah.
Caching of responses for fallback defaults and bulkheads makes sense. So that the first time you make this call, maybe it's colder, but you warm it up essentially. And then after that, your cache returns the response much faster. And then we've got on our patient data service, maybe monitoring, or rather on the database, monitoring, automated cleanup, backup planning, stress testing. I like this focus on making sure that the database maintains valid data and can serve up that valid data. All right. This is good. Y'all didn't have a lot of time, and I'm happy with kind of where you got to. In the 9 minutes, it's not a lot of time, but that's it's a microcosmic example of what we run into all the time on the job, right? We're software engineers. Everybody wants something from us yesterday. The deadline is always already passed. Everything's always an emergency. So it's really important for us to be able to slow it down a little bit, to have the tools in place to allow us to systematically analyze what needs to happen, to come out of that with some priorities for what's got to happen first, and then to have some ideas for what we might do in each of those situations where something has to happen immediately. It's really easy in our position where we're constantly the bottleneck to get caught up in the urgency of the business or the urgency of clients and those kinds of things. Urgency is important, but if we respond to that urgency without a system, if we respond negatively to that urgency, then we ended up just messing things up and pushing further and further back the things that end up needing to get done. Without having the time and the tools to be able to determine where to go from that urgency, we end up hurting things more than we're helping them. So the idea of having this system is to give you a way to say, I'm going to get on to this urgent task immediately. But the very first thing I'm going to do is not going to be jump in and hotfix the system. Instead, what I'm going to do is I'm going to determine what is going to bring us down first, fastest, and maybe like the deepest for the longest period of time. And I'm going to address that so that over time we end up with fewer urgencies and fewer emergencies. So that over time we bring our risk profile down so that the next time somebody comes to us with an emergency, it's not emergent in the sense that our core functionality is broken. It's just emergent in the sense that it's important to that person or it's important to our client, right? But it's not going to break everything right away. And we have the opportunity to address it correctly because we've managed to mitigate our own panic response. We've managed to mitigate our own kind of emotional and execution risk by having a system that we go through to make sure that our app is going to work when it absolutely needs to. Does that make sense? I know that I only have a minute left, but I just wanted to thank y'all for coming today. Super glad that we got to all meet together and do this. I know a few of you, not all of you, and so it's exciting to have gotten to meet all of you. Happy to stick around for questions for another few minutes or so, but this has been fantastic, and we'll email you. We'll send you a follow-up email with your diagrams. So if you would like to have all of these resources available later to bring back to your team, we're going to make sure that's available to you, okay?
Yeah, so that follow-up email will include like the outline that you're using for the presentation also?
Yep, it'll have everything in it. The outline, the slides, your diagrams, totally.
Thanks.
Yeah, there'll even be a template. So if you want to run this activity with your team, you can do that too.
Great.
Cool.
Well, thanks all for coming.
Yeah, thank you very much. This is awesome.
Thank you very much.
Yeah, absolutely.
Thanks.
Thank you.
Thank you.
Can I ask a question?
Totally.
Cool. A thing that I've been thinking about as we're going through this is kind of a thing our team has been thinking a lot about, which is like exception handling and like this like line between like what do you use like exceptions for? Like how do we use that as a tool? Like that between like there's so many exceptions I don't even like look at anymore, like kind of getting numb to like too many exceptions. And like I wonder if there's like some tools that you've used or ways you think about that.
About exception handling specifically?
Yeah, and like alerting and how you manage that on teams.
Yeah, it's a good question. Lately, I work with a team that does a lot of their error reporting to a thing called Sentry. You don't have to use Sentry specifically, but what it does is as our exception, we've got like thousands of people using the mobile app, and so hundreds of them might get a given exception. And maybe some of them are urgent and maybe some of them aren't. But what we can do with what Sentry does is it groups them for us. And so we can see each one is one line, and then it tells us how many times it occurred. And what I really like about that is that it gives us a quantifiable method by which to go in and figure out how we're going to prioritize those things, because that number of times that it happened serves as a proxy for us for how likely it is to go wrong, which is nice because then we can make some kind of judgment about how catastrophic each of these things are and how likely they are to, well, likely to go uncaught's not really even a concern anymore because then we have the exception. And so we get to go through the list and basically determine how catastrophic each one is, and then triage based on how often it's happening and how catastrophic it is, and create a priority list that way, which has been really nice. It doesn't feel as overwhelming. It feels like we can sort of critically analyze what's happening, even from this flood of exceptions that we're getting. And I've really liked that lately.
Cool, thanks. Yeah,
Yeah,
grouping.
totally. Yeah. Folks have other questions?
Actually,
thoughts?
I have one. It's not like workshop related, but I would like to know if you have any other reference of books. I heard you have read the Release It and Confident Ruby. Do you have any other one? Like can be like Ruby related, like software engineer related, anything you or even outside of the scope of software. So if you have anyone.
I mean, I like to read, so this is a hard question, but there's a book, so specifically kind of on the topic of this workshop, if this was interesting to you, there is a book called Why Programs Fail, and it is the best systematic debugging reference that I have seen. Now that I've said that, I want to provide some caveats on that. So a lot of the other books that I've seen have been like, when you see this specific error, maybe look for this, or when you see this, they're like recipe type of tips and tricks type of ones. This one is much more systematic, but here's what I'm going to say about it. It was written by a person who's not like a floor industry software engineer. It was written by somebody who does academic research on bugs and debugging. And so, and produces tools that are designed to be like cutting edge tools for debugging. And because they are cutting edge tools for debugging, they are not super robust yet. They don't necessarily work in whatever language you're using. And so I found it a really useful resource, but you're not necessarily going to be able to use like the specific tools that it talks to you about how to use. However, you might be able to use the intuition on which that tool is based in some system that you're using. So I'd say definitely read it. Great read. Grain of salt on the specific tools that it recommends. Does that make sense?
Totally.
Cool.
So thank you.
Lauren, do you have a rec?
Yep. I would say I would ask Lauren as well. So
gosh. So I don't know. I've heard Clean Code is good, but I haven't read it yet, so I can't really give too much of a recommendation on it.
Okay.
I do read, but not a lot about software engineering.
Okay. Anything about like you said you were like product manager? Do you have anything over it about it?
Oh gosh, about product management. I wish I could say I read books about that.
She was just
All
a
right,
natural.
nice. Okay, no worries, no worries. So guys, thank you so much.
Yeah, totally.
Thank you for
See you
joining. This
around.
was a good time.
Bye-bye.
Bye.
Thanks. Bye.
Yeah, have a good one.
Yeah, thank you very much.
Yeah, of course. Thanks for coming.
Thank you.
Of course. It was great to see